At precisely 4 minutes past 4 and 35 seconds in the afternoon on April 15, 1999, the Shanghai Seismic Bureau recorded a distinct measurement on their seismographs that appeared to resemble a small 1.6 magnitude earthquake in the MingHang district of the city. At the same time, local air traffic controllers at Shanghai's Hongqiao airport are scrambling to re-establish contact with an airplane that has suddenly disappeared from their radar screens. They look up from their radars, and out of the window they catch a view of a plume of smoke rising above the city. A massive airliner that had been on the ground just 3 minutes earlier has crashed into a residential district of Shanghai. When investigators arrived at the scene of the crash, none of them could have expected what they would uncover. One by one, explanations are dismissed. All possibilities are coming up as dead ends. It's only when the audio data is extracted from the shattered remains of the cockpit voice recorder that anything resembling a clear explanation for the accident was pieced together. It's a sequence of events that stuns the aviation world. It's the afternoon of April 15th, 1999. Shanghai is one of the largest port cities in the entire world. Massive loads of cargo pass through the city every single day. Much of it comes and goes via the way of seaports, although Shanghai also has a sizable air cargo economy. In 1999, the Shanghai metropolis was served by just one airport in the west of the city, Hongqiao Airport. As the Chinese aviation sector grew rapidly in the preceding years, plans for a new airport in the city were drawn up. Pudong International was almost finished by 1999 and was expecting to open in just a few months' time. Until then, all air traffic in and out of Shanghai went through the smaller Hongqiao Airport, which in later years would also get its own massive expansion. The Korean national airline Korean Air runs a cargo service between Shanghai and Seoul, which was also in the middle of getting a brand new airport too. In 1999, the Korean Air Cargo Division utilized a variety of different aircraft, ranging from Airbus A300s to Boeing 747s. Some of these planes were old passenger carriers that had been converted and resurfaced as cargo liners. Such was the case for the entirety of Korean Air's McDonnell Douglas MD-11 fleet. The MD-11 was supposed to be McDonnell Douglas's next-generation answer to their aging DC-10, taking a leap forward into the 1990s. The MD-11 had new engines, new avionics, and was slightly larger than the DC-10. It did have some design and operational quirks, but we'll talk about that some other time. Now, here's the thing about the MD-11. It wasn't very good. Okay, maybe that's not fair, but the plane was plagued with problems. For example, the MD-11 wasn't able to live up to the expectations in range and fuel efficiency performance that was initially outlined by McDonnell Douglas. Airlines found the plane to be disappointing, and the MD-11 performed poorly sales-wise. Pilots found it to be notoriously difficult to handle, especially on landing, but again, story for another time. In a world of new twin-engine widebodies like the Boeing 767 and Airbus A330, it was always going to be tough competition. Though a number of carriers, including Korean Air, expressed enough interest in the new wide-body trijet to place orders, the need for a third engine was antiquated, and the MD-11 fell out of favor rather quickly, worsening financial woes at McDonnell Douglas. In the end, the plane did eventually find its true calling as a freighter, and a number of them still remain in cargo service to this day. Though Korean Air began taking delivery of the MD-11s in 1992 for passenger service, by 1996, all of their MD-11 units had been converted into freighters. This happens to include this one, registered as Hotel Lima 7373. Here it is, photographed back when it served as a passenger plane. At 7 years old, the plane has racked up over 28,000 flight hours, flying all over the world across 4,500 individual flights. Interesting to note, one of those flights, a cargo service into Los Angeles in May of 1996, resulted in a nasty tail strike that required significant repair. Despite this, the accident aircraft was returned to service and continued to fly for another 3 years without incident, moving us on to the events at Shanghai on April 15th, 1999. Are you ready? Are you ready for the long, winding road to get there? Strap in. Hotel Lima 7373 is parked on stand 911 on the cargo apron at Hongqiao Airport. It's been here all day as ground handlers are busy loading it with fresh cargo for the return trip to Seoul. Scheduled for later in the afternoon is Korean Air Flight 6316. The plane is being loaded with 12 containers, a further 32 pallets of cargo, and even an airport luggage trailer, amounting to a measurable load totaling a little over 69 tons, filling up almost the entirety of the cargo space inside of the fuselage. For large freight operations like this, the payload must be loaded in accordance with the weight and balance demands of the aircraft. A plane that is too nose-heavy, for example, could cause control problems, so it is the responsibility of the ground handling crews and pilots to secure the cargo and ensure the center of gravity is within limits before taking to the skies. And you know what? Let's meet the flight crew. Piloting Flight 6316 to Seoul is 54-year-old Captain Hong Sung-sil. 35-year-old First Officer Park Bon-suk is in the right seat. Both men are competent pilots in their own right. They met all the requirements outlined by Korean Air and passed all exams to pilot the massive MD-11. Investigators would later explore the pilot's background, and not just from an airmanship standpoint. For reasons that will become apparent later, they also dug deeper into their personal lives outside of work, and they had this to say about both the captain and first officer. They didn't habitually drink alcohol and had no record of alcoholism or drug addiction. They did not possess any outstanding loans or have financial difficulties, nor did they have marital or personal problems that may have affected their state of mind. There are no existing factors that may suggest psychological burdens on them within 72 hours before their last flight to Shanghai. They were in good health and didn't take medicine before the accident flight. Captain Hong has nearly 13,000 flight hours of experience flying a variety of different aircraft for Korean Air. First Officer Park, on the other hand, is a much younger pilot, only has 2,000 flight hours to his name by comparison, though he still had substantial experience at Korean Air, beginning work on their Fokker 100s. He was promoted to the MD-11 in 1996 when they were looking for new pilots to fill all of these new freighters they had laying around. As part of their pilot training, Korean Air had introduced a crew resource management course. By 1999, CRM training had become standard for airlines globally. It was a key step forward in the world of aviation safety, as this specialized training focuses less on the technical side of operating an airplane and more on the human factors. CRM is supposed to be there to develop and improve communication and decision-making between pilots, to ensure that a flight crew is operating with and pulling from the greatest knowledge base with input from all crew members. Now, both of our pilots are new to Shanghai. In fact, this is the first officer's first trip to the airport, and the captain has only been here once before. And what we'll see as we move forward is that despite their training, communication and preparation were not exactly amongst this crew's strongest points. The MD-11 being such a leap forward from the old DC-10, this plane eliminated the third flight crew member, the flight engineer, from the cockpit. Yet there is still a third member of crew on board the plane this afternoon. Korean Air required that a flight technician be on board and fly with the plane to perform day-to-day maintenance of the aircraft. 48-year-old Park Byung-ki fulfilled this role. Though he was not officially a flight crew member, he would initially occupy a position on the flight deck prior to departure, before retreating to the small galley area immediately aft of the cockpit. The flight crew board the MD-11 and begin settling in. The captain will be at the controls today, with the first officer handling the radios. The cockpit voice recorder was live during the turnaround in Shanghai. The entire contents of the voice recorder would later be recovered, and the relationship the CVR has with the surrounding investigation is certainly an interesting one, as it would be the only surviving flight recorder. It requires that one put a lot of trust in it. It captures the movement of the flight crew as they settle into the aircraft. It picks up pre-departure checks and ATC communications. And crucially, whilst on the ground, at no point would a pre-takeoff briefing take place. Investigators would later discover the captain's poor record to perform such briefings. In preparing the plane for departure, the pilots want the weather information. they switch the radios over to the Shanghai ATIS frequency, that's the Automated Terminal Information Service. It transmits the local weather information and is updated about once an hour. The weather itself was cloudy that afternoon, with a light breeze from the south, temperature around 13 degrees Celsius. It's not perfect weather by any stretch, but it was by no means difficult to navigate for an experienced crew. By 3:44, all cargo had been loaded, the doors closed. The pilots are ready for departure. Just before pushback from the gate, there is a brief exchange between the crew members about a high break temperature reading that has drawn their attention. The flight technician chimes in to aid the captain, and the reading soon returns to normal. By 3:45, the plane is pushed back from the stand, and the MD-11's 3 Pratt & Whitney engines are fired up. A few minutes later on the taxiway, they're about to perform the after-start checklist ahead of beginning the taxi to the runway. In the flight control check, the crew manipulate the control wheel and rudder pedals, fully deflecting the ailerons, elevator, and rudder. They appear to function as normal. Moments later, they receive ATC clearance from Shanghai Clearance Delivery. It clears the flight onto their filed flight plan. It gives them their expected cruise flight level, departure instructions including where to fly to and at what altitude after takeoff, and also the departure radio frequency. A flight crew must read back this clearance correctly, and it's something we can see was done in the cockpit voice recording transcript. The captain is intrigued by something the first officer said during his readback of the clearance. He asks, 900 meters? Isn't that 1,000 feet? First of all, Captain, no, not even close. 900 meters is much closer to 3,000 feet, but he asks again to the first officer. Is it 900 meters? Yeah, 900 feet, the first officer replies. Okay, I'm gonna keep it 100 with you. This is a major plot point in how this accident turned out. The pilots appear to confuse which units they are using for altitude, the imperial foot or the metric meter. It's not just on this occasion either. This will rather incredibly rear itself again in the very short flight, with unbelievable consequences. China, unlike a lot of the aviation world, uses meters for altitude instead of feet. It's something that pilots need to get used to or even run some conversions when they fly here. Korean Air required that pilots, before acting as flight crew in and out of Shanghai, watch a video about Shanghai procedures, which had an emphasis on converting metric and imperial altitude units. The first officer had apparently only seen this video the morning of the accident. I feel like this dovetails with the lack of a takeoff briefing, as it's something that could have been discussed between crew members if they had done one, especially when we consider the crew's limited experience flying in and out of this airport. Investigators would note in their report that the crew in cockpit conversations refer to altitude clearances in both feet and meters. They wouldn't stick to using one unit, and this would serve to exacerbate a high state of confusion when they eventually get in the air. But hold on a second, let's check back in with the proverbial MD-11 in the room here. You and me both know that in aviation, the standard convention for measuring altitude is to use feet. So, why does China use meters instead? It is a bit of an oddity. You'd think on an international level pilots everywhere would use the same units, but that's not always the case. There is some history here and it might even surprise you. So, let's talk about it. Chapter 2. China. Meters. Why though? Also known as the part where I talk about aviation lore for 7 minutes, so if you don't want an earful of this, use this timestamp I guess. This is a foot. It's 12 inches. This, on the other hand, is 1 meter. It's 100 centimeters. 1 foot is equivalent to 0.3048 meters exactly. Once upon a time, in the fledgling days of airplanes, the international aviation community recognized that it was important that they got together to agree on a set of standards. You can see it, right? You can imagine how much of a pain in the ass it would be to fly from one country to another, only for them to have differences in communication or terminology, or, as is our interest today, units of measurement. Well, to address this, you'd need some sort of large international cooperative effort. There were some early get-togethers in the early 1900s in Germany, France, and Britain, which hardly materialized anything far-reaching or permanent. It was not until 1944 at the International Civil Aviation Conference, also known as the Chicago Convention, that an agreement was ratified by then 52 countries, paving the way for the formation of the International Civil Aviation Organization, ICAO. Annex 5 of the Chicago Convention recognizes the importance for a standardized measuring system. However, they also recognize that such massive standardization is not easy to implement, and there may be some differences or exceptions. ICAO emphasizes the adoption of the International System of Units. You may know that as the metric system. However, you and me both know that it ain't that simple or consistent. You may already know of certain non-standard imperial units that are in common use in aviation today. Feet for altitude, nautical miles for distance, and knots for airspeed. And that's putting it lightly. These units are ubiquitous all over the aviation world. ICAO permits these alternative units for temporary use with the international system. They put it this way because ICAO may eventually want to phase these out at some point. However, recognizing their obvious widespread use, there really isn't much of a timeline for this. Generally, most other things in aviation are measured in metric, like kilograms for weight, Celsius for temperature, and Pascal or bar scale units for air pressure, just to name a few. Now, depending on where you go, namely the United States, some of these units could be a little different. Like in America, they use pounds for weight and inch of mercury for air pressure. And this really gets to the point here, as whilst it may be helpful for everyone to agree on standard units, it's ultimately down to individual regions to decide on which of those units they use. We want to focus on altitude as it's what's relevant to the Korean Air case. The imperial foot, as we have established, is what is used ubiquitously all over the world. The same goes for nautical miles and knots. This also includes almost all countries that would otherwise use metric units for those things in day-to-day life. Despite ICAO emphasizing the metric meter for altitude all those years ago, there has been a trend towards most countries using feet over the last century or so. This may have something to do with American planes flooding the skies post-World War II. American influence with their customary units just sort of made its way to all corners of the world, and most countries standardized around that. And as a consequence, most countries use feet for altitude today. And it's just been business as usual ever since, really, with no real plan for any sort of big metric switchover. But there are a few countries where meters are used for altitude. Historically, the Soviet Union used metric measurements, and this was something that Russia and surrounding countries inherited. But again, there was that trend to align with much of the rest of the world to use feet. Today, though, you can find meters in use in places like Mongolia, North Korea, and of course, China. As you likely expected, a lot of this whole altitude situation is a combination of American influence and lingering Cold War era policy. So why does China use meters? Well, China requires its military to use the metric system, which has the side effect of requiring its airspace to do the same thing. And because Chinese airspace is so greatly influenced by military presence, perhaps this also bled over into the civilian side, and as a result, China uses meters. That's the simple explanation. Planes nowadays come with a toggle function for their instruments and autopilots to switch between units, and there is a meters mode. Here it is on the Airbus A330, here it is on a Boeing 777, and here it is on the MD-11. So what is one to make of all of this? Well, simply, when a pilot who is not from a meter-using country, when they fly into somewhere like China, it's important that they use meters. So everyone, pilots inside of their own cockpit, pilots in other aircraft, and also air traffic control, are all on the same page. I mean, sure, in an ideal world, we'd all be using the same units, but that's how it was on the day of the Korean Air accident, and it's also how it still is today in China, so pilots must navigate it. Can you take a wild guess as to what happened here? Returning to our flight, Korean Air 6316 continues its taxi up to the far north of the airport to runway 18. During the taxi, the conversation pivots to the navigational procedure after takeoff. As per their file Standard Instrument Departure, or SID, after leaving the airport, the crew can expect to fly to the November Hotel Whiskey waypoint. It's a VOR station southeast of the airport. It requires a large left turn, although the normal procedure here requires authorization from the departure controller before they make the turn. This is to ensure that there is no conflict with other traffic. A departure controller will issue the flight with the instruction when it's time. Turn on the direct after airborne. Let's make a turn at 410, the captain says. We simply can't know what was going through the minds of the pilots, though from the captain's words, it sounds like he's interpreted the departure to mean he can initiate the turn himself. Again, it's the controller who was supposed to clear them for the turn. Though he may have been unfamiliar with the Shanghai departure, a takeoff briefing may have cleared this up. He is only now trying to figure it out. Still, as the clock strikes 4 p.m. on the hour, Korean Air 6316 arrives at the runway, holding short behind another departing plane. It's a busy day at Shanghai, something the flight crew comment on. Now cleared to enter the runway, the crew bring the MD-11 into position, just in time for their takeoff clearance. Takeoff begins at precisely 4:01 and 28 seconds. The takeoff progresses as normal. Reaching the V1 and then VR rotation speed, the nose is raised and the MD-11 lifts off into the cloudy Shanghai sky. Retracting the landing gear, Captain Hong is currently manually controlling the plane. Korean Air requires that the autopilot only be engaged when the plane crosses 400 feet, and sure enough, the autopilot is swiftly switched on. Things are about to start happening very quickly. The autopilot is now feeding the MD-11 with flight control instructions. It follows what it has been told to do. This could be following the directions dictated by the flight control panel or the pre-programmed flight plan that has already been loaded into the flight computer. The flight director, that's this here, displays directional command bars on the primary flight display. It gives an indication to the pilot on where the plane should be to stay on its expected lateral and vertical flight path. Ideally, these are kept in the neutral crossed position. Again, it follows what the plane is told to do. The plane has been in the air for about 20 seconds. The captain, under the impression he now needs to turn his plane to the left, is unsure when to do so. Again, a symptom of sloppy preparation. A proper takeoff briefing would have prevented this exact type of confusion. At the same time, the flight has been handed off to a departure controller. However, now focused on this turn, it distracts the first officer when he should be handling radio communications. He initially reads back the departure frequency incorrectly. The captain begins to edge the flight controls, slowly manipulating the control wheel. "Why does this not turn?" he says. Back on the ground, the departure controller issues the flight with the expected left turn. Now when they look at their instruments, the pilots find the plane is actually turned to the right, instead of left, to a heading of 200. This is the recorded radar data, and we can see this right turn here. Now, this heading change can be explained through several possibilities: a malfunction with the heading system, a misselection of the autopilot mode, or even a possible input error into the flight management computer's navigation. But to be honest, we don't really know for sure. The pilots are caught off guard. They disconnect the autopilot, returning the plane to manual control. Recognizing the plane should turn left, they're highly confused, making this otherwise ordinary turn with difficulty. "Why is this not working?" the first officer questions. The captain, "Make it turn, it doesn't turn. Something's wrong with the plane today." This is confusing. Well, this whole incident is a confusing turn of events, but in this period of the flight, we don't entirely know what this was about. They would not specify in their conversations, and they would not relay any information to their air traffic controller. This high state of confusion would sustain itself for the rest of the flight. So, was there something wrong with the plane? I mean, if we're talking about turning the plane, does this suggest a problem with the flight control system? Well, based on the findings of investigators, such an assessment is doubtful. Whilst investigators couldn't rule out that there were no faults whatsoever with the plane, later analysis of the wreckage revealed that the flight controls, at least, were in full working order during the flight. Though the crew seemed to have difficulty in getting the plane to turn left, it does not appear to be a problem with the lateral control or other systems, because the crew could keep the plane in level flight and in a steady climb. The crew did not mention any specific airplane or airplane system anomaly in their discussion. Furthermore, they didn't request a return to the airport, all of which indicates that the airplane flight control and operating systems were functioning normally, as well as the pitch control. So, what was going on here? Well, no doubt they had gotten themselves into an abnormal situation. However, to be honest, given the lack of evidence, as we don't have a flight data recording to clue us in, and because the pilots did not clearly specify, using words like "look at this" and "I don't see," things like that, it's impossible to know. Maybe there was some confusion with the autopilot or with where the plane was going, but ultimately, whether they knew it or not, they had full control of the aircraft. Further demonstrated as the captain now begins to turn the plane, albeit slowly to the left as expected, maintaining a steady climb. As the turn continues, the captain laments, "I don't see where." Investigators speculated with reasonable plausibility that the captain was looking at the navigation display whilst doing this turn, but he may not have been able to see the November Hotel Whiskey waypoint on his screen. It's possible that the nav displays between the two pilots may have been configured to different range settings. Investigators reckoned the captain's navigation display was zoomed in as for the waypoint to be off screen. The first officer was able to lend a hand as his display may have been at a greater setting, as we have this example of the first officer giving direction. "Yes, here, keep turning left. Keep turning left." The first officer is now guiding the captain on where to fly. The plane is really slipping out of their hands here, and the Shanghai departure controller is perplexed, watching on their radar screen as the plane is turning late and slowly. 4:03. The plane has been in the air for a little over 1 minute, and the MD-11 has leveled off at 900 meters, around 3,000 feet. The pilots retract the flaps as normal, awaiting a further climb. Although 900 meters is not quite the altitude that ATC instructed. In the background during all of this, Shanghai Departure had been issuing a further climb up to 1,500 meters that the crew had not yet acknowledged. Departure naturally repeats the instruction again and again. Korean Air 6316, climb and maintain 1,500 meters. It is here we reach the critical point in the accident sequence. What happens next is based on the findings of the International Joint Investigative Team. The captain, busy trying to navigate the aircraft, is distant from the first officer who gets on frequency to acknowledge. 1,500 meters, Korean Air 6316. The MD-11 re-enters a steady climb and breaks into the lower cloud layers. We can see in this transmission that the first officer recognizes the climb in meters. At the same time, the flight crew again become preoccupied with navigating the plane. The first officer calls out "pitch" to the captain, possibly referring to the flight director bars on the primary flight display with the onset of the new climb. But it's when the captain asks for this new altitude, the first officer gives this response. "How far did they tell us to climb?" the captain questions. First Officer Park Ban-suk replies with this fateful line, 1,500 feet. Though just moments ago he correctly read back the climb in meters to ATC, he has now just directed the altitude information to the captain in feet. 1,500 feet and 1,500 meters are completely different altitudes, but he does it again. First Officer Park reaffirms the wrong altitude twice as 1,500 feet. If we think about this from the captain's point of view for a moment, it's been confirmed that they should actually be at 1,500 feet, which is incorrect. At their current altitude, now climbing through 1,300 meters, somewhere in the region of 4,500 feet, he thinks the plane is now far too high, and to him, Being so wildly off base when it comes to altitude can be dangerous, which is true if that were the case. The co-pilot miscommunicating the altitude is one thing. The awkward navigation after takeoff is another. But what investigators believe happened next was simply a massive overcorrection from the captain, and the real cause for the loss of the plane. The captain wants to go down and so initiates a rapid descent. The control wheel is abruptly pushed forward, the throttles closed, and the stabilizer trim is over-trimmed forward. Over the course of just a few seconds, the nose pitch swiftly changes from a steady climbing nose-up attitude to an extreme negative nose-down attitude. In the clouds, unable to see much through the whiteness of the windows, the captain doesn't realize how far the plane has been pitched forward. Without realizing it, they have overreacted. They've just put the plane into a nosedive at less than 5,000 feet. It's only when the plane breaks free of the clouds and the ground fades into view that the gravity of the situation sets in. The first officer notices and calls out the pitch situation to the captain. Wait, pitch, he says. The captain acknowledges. Unfortunately, by the time they had noticed or spoken up, it was already too late. The plane had now been tipped over to negative 35 degrees. The whole plane rattles as the massive jet exceeds 350 knots, achieving a monumental descent rate that peaks at 30,000 feet per minute. The plane is pushed to its limits. The captain is trying to recover his plane, but is experiencing great difficulty as he's battling great forces now acting on the aircraft. The MD-11 already has a reputation of being a tough one to handle, and here the captain is trying to pull it out of a dive. The ground proximity warning system sounds in the cockpit. It's only been a matter of seconds since the crisis began. The first officer exclaims that they need to pull the plane out of it. Both pilots are desperately pulling on their control wheels to bring the situation under control. Slowly, the MD-11 begins pitching up, but there simply wasn't enough altitude to perform a successful recovery. At 4 minutes past 4 and 34 seconds in the afternoon, Korean Air Flight 6316 crashes into a residential neighborhood in the MingHang district of Shanghai. The massive MD-11 explodes and shatters on impact. It was powerful enough to signal nearby seismic surveillance stations, and their equipment registers the crash as a small earthquake. All 3 people on board the ill-fated plane, the captain, first officer, and flight technician, are killed. The plane had crashed into a migrant housing facility, which resulted in the deaths of a further 5 people, including a child, injuring dozens more. The death toll rises to 8. This is a truly devastating accident, one that was ultimately put down to pilot error, a loss of situational awareness. Korean Air rejected the findings of the investigation on the grounds that the blanks could only be filled in with the cockpit voice recorder. Others claim there may have been a possible defect with the plane, and without the flight data recorder, many questions remain unanswered. If we are to stay open-minded, if there was a sufficient defect to the degree of bringing down a massive plane like the MD-11, it may be worth examining what the investigation found. Following the accident, an international joint investigative force was assembled to establish why this plane seemingly just fell out of the sky. I don't have a Korean Air MD-11 model, I only have this KLM one. I couldn't find one, so one that was this size anyway, so we're just gonna have to improvise, I think. Really, this is KLM making its way into another video it doesn't belong in. Anyway, the accident occurred on Chinese soil, so the Civil Aviation Administration of China was assigned to the job. Although, because this was a Korean-registered plane and an American-manufactured aircraft, the Korean Civil Aviation Bureau and the American National Transportation Safety Board were brought in as part of the team. The NTSB has a long positive track record of being proactive in international investigations, and their involvement would turn out to be paramount for reasons we're about to get to. For investigators, when they got to the accident site, they arrived at exactly what you think. A scene of total devastation. The plane was completely obliterated, and it was difficult to distinguish which parts were plane and which parts were building or ground-related, though there were some clues hidden amongst all of it. The wreckage of the plane was distributed in this distinctive fan-shaped pattern, spreading out in a southeasterly direction. This gave investigators an idea as to how the plane might have impacted. They were also able to salvage the standby instruments from the cockpit, which provided more of a snapshot into the plane's final moment. This was a high-speed impact. Wings level somewhere between 20 and 40 degrees nose down at a speed of nearly 400 knots. Call that 740 kilometers per hour. Airplanes have flight recorders on board, the black boxes, which are actually orange. And these provide an inside look as to what was going on. I mean, sure, you can work backwards from the wreckage, and historically, many key investigations have. However, a recording of some kind from the inside during the event as it happened can be invaluable. This MD-11 had 3 flight recorders on board: the cockpit voice recorder, the flight data recorder, and the quick access recorder. All of them had been heavily damaged in this case. The flight data and quick access recorders were pretty much completely destroyed in the accident and post-crash fire. The investigation had to discard them as no information could be retrieved. This left the cockpit voice recorder, which looked more promising. This CVR was a newer solid-state memory card type device, and not the old-fashioned tape recorder kind. Though it was heavily damaged, most of its contents was saved. The only part of the cockpit voice recording that was lost was a small section from Channel 4, which was actually connected to an overhead microphone inside of the cockpit. Though this was from the first 30 minutes of the recording, which actually covered the approach into Shanghai and the turnaround, so it wasn't all that relevant anyway. The full recording, though, from pre-departure to the moment of the crash, was there. The NTSB would lend a hand and transport the CVR to the United States for further spectrograph analysis, and they would even revisit the recording on at least 2 occasions to revise and make corrections to it. It took about a year for a final transcription of the recording to be finalized. Therefore, the NTSB is confident that the transcript is to the best of their ability, having considered that for the most part the pilots spoke Korean, and translations were carefully done with that in mind. However, the NTSB cautions that no conclusion should be based on the CVR alone. I mean, sure, it's an extremely useful investigative tool, but it should be used in combination with other evidence. So, investigators began to explore several scenarios. First, the weather. Could the plane have encountered some sort of meteorological anomaly, a devastatingly powerful downdraft that plunged the plane into a deadly dive? No. Not even close. The weather was fine and was quickly ruled out. Second, a weight and balance shift. Cargo planes carry a lot of freight, naturally. You can imagine then how if all of that cargo somehow tumbled to one end of the plane, it could cause a loss of control. Something like that has happened in other accidents. Investigators looked at the freight manifest and determined that there couldn't have been such a dramatic shift in the weight. So much cargo had been loaded inside of the plane that it barely had any room to move at all. The records show the plane was loaded within weight limits and balanced appropriately. The ground handlers working the plane that day also revealed that there were no abnormalities during the loading process either. Third, and this is a big one, a mechanical failure of the horizontal stabilizer. The horizontal stabilizer is this structure at the back of the plane. It can be pitched up and down with stabilizer trim, which is controlled either manually in the cockpit or automatically via the autopilot. Now, on the MD-11, and a lot of other planes in fact, pilots have an easy-to-use trim switch, which can be found directly on the control wheel itself. But please note that this is not the same as elevator controls, which are linked to the movement of the control wheel. We'll talk about that in just a moment. A failure or sudden deflection of the stabilizer was ruled out, as, well, firstly, there had been no prior history of defects with it on this aircraft. And in the event of an out-of-control stabilizer or a jam, a pilot should still be able to recover with elevator controls. Now, interestingly, on the cockpit voice recording, investigators could hear the stabilizer motion alert of the central aural warning system.
Stabilizer motion.
That That was heard a few times during the crisis, which suggests that there was stabilizer deflection, but it was gradual, which is consistent with the investigation's findings that this occurred because they had over-trimmed the aircraft forward when they wanted to go down. For a stabilizer failure to be what caused this accident, something similar to what happened to Alaska Airlines 261 would have to have occurred, meaning the whole mechanical stabilizer assembly would have to have destroyed itself as to cause separation or deflection far beyond its limits, which there is absolutely no evidence for. In fact, the wreckage kind of suggested the opposite. In the wreckage, the jack screw assembly which drives the stabilizer motion was recovered, the position of which indicates that the stabilizer was well within limits. Ultimately, a failure with the horizontal stabilizer was ruled out. Fourthly, a jammed elevator. The elevators can be found as part of the horizontal stabilizer structure, and these are directly linked to the control wheel in the cockpit. Pushing and pulling the control wheel actuates the hydraulic system that moves the elevators up and down. A jamming of this system could help explain it, but this doesn't seem to work when you think about it. I mean, if an elevator jam did occur, wouldn't it have jammed in a nose-up position? It doesn't really explain the sudden dive, and an extreme nose-down jam would have manifested in a debris field consistent with an impact angle in the range of 70 to 90 degrees, and not the 20 to 40 observed at the accident site. So mechanical failure wasn't the answer they were looking for. NTSB analysis of the hydraulics, actuating systems, and overall flight controls relating to the ailerons, elevators, rudder, and flaps yielded little results. Some contamination of hydraulic fluid was found, but this did not impede the normal operation of the plane. It appears, therefore, the plane was in full working order during the accident flight, although I should add that investigators couldn't rule out that there were no faults whatsoever with the plane, but they were confident at least it wasn't the cause of the accident. Just gonna adjust my apron here, hold on a second. Can't find the bow. There we go, nice and tight. Radar data heats things up a bit as it helped to plot the trajectory of the plane. Shanghai, like many airports, has secondary surveillance radar, which in 1999 was standard at major airports. Though greater in complexity than standard primary radar, SSR still works on a very basic principle. A radar sends out a request or interrogation signal, and the plane replies to it. It's a communication between the station and the aircraft. The plane, via the transponder, can reply with various bits of information about itself, including altitude. What this means is that even without a flight data recorder, with the radar data extracted from Shanghai, we have, at least to some degree, a 3D flight path of the accident flight. We know where the plane went and what altitude it was at various points. Now, it needs to be said, simulation testing could not duplicate the same flight path through a stall, runaway stabilizer, or an elevator malfunction, or some other anomaly. It turns out that the only way the plane could have peaked at around 1,500 meters at this location, but then also crash in this location, for it to get from here to here in that short space of time, it had to have been done deliberately. Next, sabotage, or rather specifically, unlawful interference from someone other than the flight crew. Was the flight hijacked? It has happened before, and on cargo flights, no less. The cockpit voice recording would eliminate this possibility entirely, but it does point in the direction of another human scenario that investigators did consider. Did a pilot do it? Through premeditation or as a result from a medical condition? It is troubling to think about, but it has happened before, and it has happened since. This is why investigators dug deeper into the pilots and their personal lives. Both pilots were healthy, had not consumed any medicine, were free of alcohol or substance abuse, they were financially stable, had strong personal lives with nothing to suggest that either of them would do such a thing. Having considered numerous possibilities, knowing that the sudden attitude change from nose up to nose down had to have been done via deliberate flight control inputs, listening to the full recording with everything from the pilot conversations to the sounds of the switches, dials, and alerts, investigators were able to put all of that into context, and they built an image of what happened. I'll just let them explain themselves. The crew reconfirmed the wrong altitude, and abruptly pushed the control column forward and over-trimmed the horizontal stabilizer forward. The crew mistook the cleared altitude twice of 1,500 meters for 1,500 feet in cockpit conversations. The above-mentioned evidences indicate that the accident plane's sudden dive was at the wish of the crew rather than other causes. This was an accident in its simplest form, a miscommunication then following through into a massive overcorrection over a perceived altitude error. It's a baffling accident, but still an accident nonetheless. Safety recommendations issued by the investigation mainly fell along the lines of pilot training, leveling criticism at Korean Air. They recognized the pilots were unprepared for abnormal situations. There was no strict adherence to policy, pilot duties were scattered, and there was generally a lack of decent communication between the crew. Regarding the misuse of incorrect altitude units, the investigation stresses that there should be greater international cooperation to avoid confusion between differing units. Where one unit is established, there should be clear emphasis on that one unit being used. Investigators recommended that Korean Air overhaul their crew resource management training and emphasized reinforcement of operational procedures as, for example, to not let takeoff briefings go by the wayside in the way it did here. The loss of this plane came at an interesting time for Korean Air. The airline had a tattered safety record following a string of notable incidents throughout the 1990s, including several crashes, one of which was one of the deadliest air disasters to have ever occurred. The Shanghai case was just one in a string of many. In fact, it was the second of 3 hull losses at Korean Air in 1999 alone. A common theme amongst the Korean Air accident reports is the weight of insufficient pilot training and systemic flaws within the company. When the news broke that a modern Korean Air MD-11 crashed into a Shanghai neighborhood, Delta Airlines, citing safety concerns, suspended their code-sharing agreement with Korean Air. The then president of South Korea called the airline a national embarrassment, so, as you can imagine, things weren't great over there. Something was going on, and there needed to be change at the airline. And change there was. Korean Air was audited. Internal reviews and safety recommendations led to sweeping reforms at the airline, and the result has been a dramatic change. Korean Air's own safety record reflects this, as there has never been a fatal incident since 1999. The airline is now considered to be amongst the safest in the world, and as a founding member of the SkyTeam Alliance, they're an airline that other carriers do want to associate with. Korean Air continues this streak to this day. They've expanded, having recently acquired Asiana Airlines. Also, whilst I was making this video, Korean Air has rebranded, unveiling a new livery, and I don't exactly have the highest opinion of it. I mean, look at how they massacred it. Granted, it's not as bad as other livery downgrades, looking at you, Aer Lingus. A further deep dive into Korean Air and just how the airline wound up in such a state is worth its own video at a later date. There is a lot to say about it, more than what's been said here, and it is worth exploring at least one other Korean Air case for its relationship to a narrative that warrants deep analysis and criticism, but we'll save that for a later date. Hello everyone, thank you so much for watching. Welcome to the end of the video. Let me tell you, I did not expect this one to take so long to make. I'm sorry to keep you waiting, I thought this one would only take me like a couple of weeks to produce. So, I'll not keep you here long, and we'll have a bit of a swift outro this time. Though, to keep it real with you, I do love making these long videos, and you viewers seem to love them too, which is great. Thank you so much for watching. I do post about the upcoming videos from time to time over on my social media, Twitter and Blue Sky, so I will leave links to those in the pinned comment and description if you'd like to follow me there. Anyway, it is that time. the time to thank and show appreciation to my amazing patrons over on Patreon who have generously contributed to the channel, helping make these long videos possible and, at least right now, also sponsor-free. Their names are scrolling on the screen right now, so if you see your name here, a massive thanks to you. As always, we have a number of shoutouts to get through today. Firstly, beginning with the new business class tier patrons. We only have 2 of them this time, so a big thanks, in order of which they joined, to Teresa and Nexi. Thank you so much. Up in first class, I'd like to give big thanks to Anthony Trains, G Funk the World, Lawrence K, Pete Warden, Keith Bopp, Juliana Baumgart, Spartan for Life, David Kalla, and Elodie Lilith. What absolute legends, the whole lot of you. Legends, thank you all so much. If you, my viewer, yourself would like to support the channel further, the Patreon is always there and you can join from as little as £1 per month. The link to that will be in the pinned comment and description of this video, again along with my socials. That is where I'm going to leave you for now. I am finally going to shut up. Thank you all so much for watching, have a lovely day, and I will see you again very soon. Goodbye! Well, that's another video over with. And I believe it is Easter time. It's like April, right? This video's going out in April. So I thought I would dress for the occasion. Now I'm a bunny. And I also got this Easter egg. I figured we could open an egg to celebrate, you know, just something a bit different for the post-Patreon scene. Egg. It rattles. It's got eggs inside. Eggs. Eggs. Oh! Oh no, I dropped one. Egg. Oh. Ah! Happy Easter, everybody. Uh-oh. Oh no! Oh no! Please like and subscribe. Oh my god. Okay. Bye!